Hello everyone, and welcome to our deep dive into the intricate world of electronics. Ever wondered what lies at the heart of our computers and how it's crafted? Today, we're unraveling the mystery behind the motherboard, the central hub of our PCs. We'll explore the materials that go into making them and the detailed manufacturing processes that transform raw materials into the technological marvels that power our daily tasks. The manufacturing of motherboards is a complex process that involves multiple stages. Motherboards, being the main circuit board in computers, have various components attached to them and are made of different materials. Here's a detailed breakdown of how they're made and what materials are involved. Materials. Substrate. The base material of a motherboard is often a rigid type of fiberglass called FR4, flame-resistant 4, which provides the structural integrity for the board. This fiberglass is coated with a layer of copper, which is then etched away to leave behind the pathways, traces, that conduct electricity. Copper. Used to create the pathways or traces for electrical currents on the motherboard. Some motherboards have multiple layers of copper traces. Solder. This is used to attach components to the motherboard. It's an alloy typically made of tin, lead, and other metals, though lead-free solders are becoming more common due to environmental and health concerns. Silicon. Used in the manufacturing of microchips, including the motherboard's chipset. Plastic. For sockets, slots, and other parts of the motherboard. Various metals. For connectors, slots, and heat sinks. This can include gold, for high-quality connectors, aluminum, common in heat sinks, and other metals. Other materials. Capacitors might be made of ceramic, tantalum, or electrolytic materials. Resistors, inductors, and other components also have their own material makeups. Manufacturing process. Design. Before physical manufacturing, the motherboard's layout, including where each component goes and the routing of electrical pathways, is designed using computer-aided design, CAD, software. Substrate preparation. The fiberglass substrate is prepared and coated with a thin layer of copper. Photolithography. The motherboard design is printed onto a film. This film is placed over the copper-coated substrate, and the board is exposed to ultraviolet light. The exposed areas harden, and the unexposed areas remain soft. Etching. The board is then subjected to a chemical that removes the unhardened copper, leaving behind copper traces that match the design. Laminating. For multi-layer motherboards, several layers of etched substrates are laminated together. Drilling. Holes, vias, are drilled to connect the various layers of the motherboard. Component placement. Components, like capacitors, resistors, sockets, and chipsets, are placed onto the board. This is often done by automated machines for precision. Soldering. The components are soldered onto the board. This can be done using a process called reflow soldering, where solder paste is applied to the board, components are placed on top, and the entire assembly is heated so the solder melts and forms solid connections. Testing. The motherboard is tested for functionality and performance. This might include applying power and running a diagnostic program to ensure all components function as expected. Packaging. Once tested, motherboards are packaged with protective materials and are ready for shipping. The production of motherboards is a sophisticated process that requires precise coordination and quality control. This is why there are only a handful of major manufacturers in the world capable of producing them on a large scale. As we wrap up, it's evident that the making of a motherboard is no less than a marvel of modern engineering. Combining a plethora of materials and utilizing state-of-the-art manufacturing processes, these boards serve as the silent backbone of our computing world. Next time you boot up your computer or play a game, remember the intricate dance of materials and processes that make it all possible. Thank you for joining us on this journey, and stay curious about the tech that surrounds us.